Okay, some of the attacks we'll see in little detail. So UDP flood attack. An attacker sends spoofed UTP packets at a very high packet rate to a remote host or on random ports of a target server by using a large source IP range. Causes the server to check repeatedly for non-existent applications at the ports. Legitimate applications become inaccessible by the system. Consumes network resources and available bandwidth. ICMP flood attack. ICMP is used by network admins for troubleshooting and error message sending for undelivered packets. Send large volumes of ICMP echo requests to victim. These packets signal the victim's system to reply. To protect against ICMP flood attacks, it is necessary to set a threshold that invokes the ICMP flood attack protection feature when exceeded. When the ICMP threshold is exceeded, by default the threshold value is 1000 packets per second. So when it is exceeded, the router rejects further ICMP echo requests. Ping of death attack (POD) sends malformed or oversized packets using simple ping command, size of 65538 bytes to the target web server, which is more than limited prescribed by the which is more than the limit prescribed by RFC 791 IP. So the limit is 65,535 bytes. So if you send 65,538 bytes, then the server might crash. Smurf attack. The attacker spoofed the source IP address with the victim's IP address and send large number of ICMP core request packets to an IP broadcast network. Somewhat similar to amplify attack, which is one of the type of volumetric attack. The other one was flood attack. Now it is easy to guess later what happens, right? So when the echo request packets are sent to broadcast network with a spoofed IP address, the broadcast network will start responding with the ICMP echo responses, but it will be from many systems in the broadcast network to the victim's IP address, as the attacker has had spoofed the source IP address. So now the victim's system might crash. Next is pulse wave DDoS attacks. Latest type of DDoS attack. Generally, DDoS attack patterns are continuous incoming traffic flows. The attack pattern is periodic and the attack is huge. The attack can last for hours or even days. Zero-day DDoS attack. Attacks in which DDoS vulnerabilities do not have patches or effective defense mechanisms. No protection for this attack, obviously, because there is no patches for this. SYN flood attack. The attacker sends a large number of SYN requests to the target server with fake source IP addresses. The victim's listen queue is quickly filled up. The ability to delay each incomplete connection for 75 seconds can be used cumulatively as a denial of service attack. This is an example of protocol attack that we discussed initially, where the attacker consumes types of resources other than bandwidth, like connection state table. So this SYN flood is an example of a protocol attack. SYN act flood attack. This type of attack is similar to SYN flood attack, except that in this type, the attacker exploits the second stage of a three-way handshake by sending a large number of SYNAC packets to the target machine to exhaust its resources. ACK and pushback flood attack. During an active TCP session, ACK and pushback are the flags used to transfer information to and from the server and client machines till the session ends. In an ACK and pushback flood attack, the attacker sends a large amount of spoofed ACK and pushback packets to the target machine, making it non-functional. Fragmentation attack sends a large number of fragmented packets to a target web server with a relatively small packet rate. The content in the packet fragments is randomized by the attacker. So here small packet rate is the key. The rate is very low, but it will send a large number of fragments. So because the rate is less, the server will take time to receive all the packets and then to construct it back. On top of that, the fragment order is also randomized. This will take more time for the server to assemble the fragments. Spoofed session flood attack. Attackers create fake or spoofed TCP sessions by carrying multiple SYN, ACK, and RST or FIN packets. HTTP get or get/post attack. HTTP clients such as web browsers connect a web server through the HTTP protocol to send HTTP requests. This request can be either HTTP get or HTTP post. In an HTTP GET attack, attackers use a time-delayed HTTP header to maintain HTTP connections and exhaust web server resources. In HTTP POST attack, attackers send HTTP request with complete headers, unlike in the HTTP GET attack. But here, the message bodies will be incomplete. So the web server or application will keep on waiting for the rest of the message body. This attack aims to compel the server to allocate as many resources as possible to serve the attack, thereby denying legitimate user access to the server's resources. So this is the diagram of HTTP GET and POST attack. As you can see, attacker request with time delayed HTTP header in case of HTTP GET attack. Time delayed HTTP header. So the target server will be waiting for the complete header in case of HTTP GET attack. In case of post attack, request with incomplete message body will be sent, though the target server will be waiting for the message body. Next attack is slow loris attack. Slow loris is a DDoS attack tool used to perform layer 7 DDoS attacks to take down web infrastructure. It is distinctively different from other tools in that it uses perfectly legitimate HTTP traffic to take down a target server. In slow loris attacks, the attacker sends partial HTTP requests to the target web server or application. Upon receiving the partial request, the target server opens multiple connections and wait for the request to complete. However, this request remain incomplete, causing the target server's maximum concurrent connection pool to be filled up and additional connection attempts to be denied. UDP application layer flood attack. Though UDP flood attacks are known for their volumetric attack, some application layer protocols that rely on UDP can be employed by attackers to perform flood attacks on target network. Examples of UDP application layer attack: character generator protocol, CARGEN, simple network management protocol version 2, SNMP version 2, quote of the day, QOTD, remote procedure call, SSDP, connectionless lightweight directory access protocol, CELDAP, trivial file transfer protocol, network basic input output system NetBIOS, NTP, Quake network protocol, Steam protocol, voice over internet protocol. So these are some of the examples of the application layer protocols that can be attacked. So next is multi-vector attack. In multi-vector DDoS attacks, that attackers use combination of volumetric protocol and application layer attacks to disable the target system or service. Attackers rapidly or repeatedly change the form of their DDoS attack. Example, SYN packets, layer 7. These attacks are either launched one vector at a time or in parallel to confuse company's IT department and exhaust their resources with their focus diverted to the wrong solution. Peer-to-peer attacks. Attackers exploit flaws found in the network that use the direct connection protocol, which allow the exchange of files between instant messaging clients. This kind of attack does not use botnets. Unlike a botnet-based attack, a peer-to-peer attack eliminates the need for attacker to communicate with the clients they subvert. Here, the attacker instructs the clients of large peer-to-peer file sharing hubs to disconnect from their peer-to-peer network and instead connect to the victim's website. Consequently, several thousand computers may aggressively attempt to connect to target website, causing a drop in the performance of the target website. Permanent denial of service attack. Permanent DOS or PDOS attacks, also known as flashing, purely target hardware and cause irreversible damage to the hardware. Unlike other types of DOS attacks, it sabotages the system hardware, firmware, requiring the victim to replace or reinstall the hardware. The PDoS attack exploits security flaws in a device to allow remote administration on the management interfaces of the victim's hardware, such as printers, routers, and other networking devices. Distributed reflection denial of attack, uh, DRDoS, denial of service attack. A distributed reflected denial of service attack, DRDoS, also known as spoofed attack, involves the use of multiple intermediary and secondary machines that contribute to the actual DDoS attack against the target machine or application. Attacker launch this attack by sending requests to the intermediary hosts, which then redirect the request to the secondary machines, which in turn reflect the attack traffic to the target. Advantage, the primary target seems to be directly attacked by secondary victim rather than the actual attacker. Multiple intermediary victim servers are used, which results in an increase in attack bandwidth countermeasures. Um, okay, some of the countermeasures are turn off character generator protocol, CharGen service to stop this attack method. So turn off the CharGen service. Download the latest updates and patches for the services. Okay, in the next video, let's go to the next module flow, that is botnets.